The James Webb Space Telescope has captured something truly extraordinary. Lights that appeared to shimmer like a distant city, glowing from a world just over 4 light-years away. This incredible finding has reignited one of humanity's oldest and most profound questions. Are we truly alone in the universe? The telescope focused its powerful gaze on Proxima Centauri b, the nearest known exoplanet to our solar system. What it found was nothing short of astonishing, strange, rhythmic flashes of light emanating from the planet's dark side. These weren't the natural flickers of stars or the reflection of solar radiation. They were sharp, patterned, and hauntingly familiar, like the glow of an alien metropolis under an endless night sky. Could this truly be evidence of an extraterrestrial civilization? Or is there another, more natural explanation waiting to be uncovered? For centuries, humanity has gazed upward, wondering if the stars host other intelligent beings. Every hint of life beyond Earth, from faint radio signals to unusual atmospheric gases, has sparked waves of excitement and hope. But now, with the James Webb Space Telescope, we may be closer than ever to answering that question. While scanning the cosmos in high-resolution infrared, the telescope captured a sequence of luminous patterns on Proxima Centauri b that defied conventional explanation. The light signatures resembled those produced by artificial illumination, the kind found in human cities seen from orbit. This observation has ignited scientific debate around the world, drawing attention from NASA, the European Space Agency, and independent astronomers alike. Dr. David Kipping, an astronomer at Columbia University, described the discovery as a potential game-changer. According to him, Proxima b is no ordinary rocky planet. Unlike most exoplanets that simply absorb sunlight and emit heat in infrared, Proxima b behaves differently, likely due to its unusual orbit and close relationship with its parent star, Proxima Centauri. The James Webb Telescope's ability to detect faint infrared wavelengths played a crucial role in this finding. Its powerful instruments allowed scientists to distinguish between thermal emissions from the planet's surface and reflected light that may not originate from natural sources. This fine sensitivity is what makes the James Webb Telescope one of humanity's most important tools in the ongoing search for life. Researchers plan to continue using this advanced telescope to study the atmosphere of Proxima b in greater depth. If the planet has an atmosphere, its chemical composition could provide vital clues about its ability to sustain life. Elements such as oxygen, methane, and water vapor would suggest that the planet is not only habitable, but potentially inhabited. The challenge, however, lies in separating natural phenomena from potential artificial ones. Many telescopes struggle to detect faint light across the vastness of space. But the James Webb Telescope excels in this area, capable of picking up the faintest flickers that most instruments would miss. This makes it the perfect instrument to confirm whether these supposed city lights are truly real. Proxima Centauri b exists in a delicate balance with its parent star. The planet is tidally locked, meaning one side permanently faces the star, bathed in eternal daylight, while the other remains shrouded in darkness. The bright flashes were observed from this dark side, a place where natural light is scarce, making artificial illumination all the more suspicious. If the planet lacks a protective atmosphere, its surface could experience wild temperature fluctuations, scorching heat on one side and freezing cold on the other. Yet, the presence of consistent light emissions from the night side challenges this idea. Could these lights be energy bursts from geological activity, volcanic eruptions, or perhaps something far more advanced? The James Webb Telescope's infrared imaging provides critical insight into these mysteries. By measuring the planet's thermal emissions, scientists can estimate surface conditions and atmospheric dynamics. Intriguingly, Proxima b's temperature patterns suggest heat redistribution, a sign that it might indeed have an atmosphere capable of trapping warmth, similar to Earth's greenhouse effect. Every 11.2 Earth days, Proxima b completes an orbit around its star. During each cycle, the telescope collects detailed data on the planet's brightness variations, helping astronomers determine whether the observed lights fluctuate naturally or follow a predictable artificial rhythm. If these variations repeat with mathematical precision, it could strengthen the case for intelligent origin. The next step is analyzing the planet's light spectrum. When starlight passes through a planet's atmosphere, certain wavelengths are absorbed by gases. By studying these absorption patterns, scientists can identify the planet's chemical makeup. The discovery of oxygen, water vapor, or methane in specific ratios would point strongly toward biological or even technological processes. While the James Webb Telescope excels at detecting carbon dioxide, methane, and water vapor, it's less capable of spotting free oxygen, one of the clearest indicators of life. Even so, it can still detect ozone, a byproduct of oxygen that signifies a stable, life-supporting atmosphere. Future missions may rely on even more advanced instruments to confirm what the James Webb Telescope has started. Of course, one telescope alone cannot observe everything. The James Webb's reach is limited to exoplanets within a certain distance. For deeper analysis, scientists are already preparing ground-based successors like the Extremely Large Telescope, ELT, set to begin operations in 2028. The ELT will offer a sharper view of distant worlds, allowing astronomers to peer directly into their atmospheres and surface compositions. These next-generation telescopes will push the boundaries of what we can see. By using advanced light filtering systems, scientists can block out the overwhelming glare of stars to reveal the faint reflections from orbiting planets. Imagine holding your hand over the sun to see what's behind it. That's essentially what these telescopes aim to do. One key innovation is the coronagraph, a device built into telescopes to mask starlight while allowing planetary light to pass through. By carefully shaping light waves, coronagraphs reduce stellar glare, revealing the dim glow of exoplanets in stunning detail. Another groundbreaking concept is the starshade, a massive, flower-shaped spacecraft that travels in formation with the telescope. From tens of thousands of kilometers away, the starshade physically blocks the starlight before it even reaches the telescope, allowing only the light from orbiting planets to be captured. This technology could make it possible to directly observe planets in the habitable zone, the regions where liquid water, and perhaps life, might exist. These methods require extraordinary precision. The starshade's alignment must be accurate to fractions of a millimeter over colossal distances, a nearly impossible engineering feat. Yet, if successful, it could revolutionize our search for alien life. By combining these technologies with advanced adaptive optics, systems that correct distortions caused by Earth's atmosphere, future telescopes may not only detect exoplanets, but also map their surfaces, study their weather systems, and identify biosignatures such as vegetation pigments or industrial pollution. Such discoveries could forever change our understanding of the cosmos. Imagine seeing the first confirmed image of alien lights flickering on the horizon of another world. Proof that intelligence, somewhere out there, looked back at the stars and wondered the same thing we do. The James Webb Space Telescope is only the beginning. Each new observation, each beam of light that reaches us across the void, brings humanity closer to unlocking one of the greatest mysteries of all. Are we alone? As technology advances, the answers that once seemed out of reach are now shimmering faintly on the edge of discovery. Perhaps, hidden in the glow of Proxima Centauri b, we are witnessing the faint heartbeat of another civilization, one that has been waiting quietly for us to notice. This is Discovery at 2.0, where science meets wonder, and where every star hides a new story waiting to be told. If you enjoyed this exploration, don't forget to like, share, and subscribe for more cosmic discoveries. Because somewhere, just 4 light years away, a light is still shining, and maybe, it's looking right back at us.